Here's something that might surprise climate skeptics and believers alike. Scientists from 3 decades ago got it almost perfectly right about our rising seas. A groundbreaking analysis has just revealed that climate researchers from the mid-1990s predicted sea level changes with shocking precision. And this discovery is stirring up conversations that some people definitely don't want to have. But here's where it gets controversial. While their overall predictions were spot on, they dramatically underestimated one crucial factor that could change everything. For over 30 years, satellites have been quietly watching our planet's oceans rise, creating an unprecedented record of global sea level changes. 2 scientists from Tulane University recently dove deep into the satellite data and compared it with predictions made back in 1996. And what they found should make everyone, regardless of their stance on climate change, sit up and take notice. The ultimate test of climate projections is to compare them with what has played out since they were made. But this requires patience. It takes decades of observations, explains Torbjørn Turnquist, the lead researcher and Vokes geology professor in Tulane's Department of Earth and Environmental Sciences. The results, published in Earth's Future, an open-access journal from the American Geophysical Union, are nothing short of remarkable. The 1996 Intergovernmental Panel on Climate Change Assessment predicted that global sea levels would rise by approximately 8 centimeters, about 3 inches, over the following 3 decades. The actual measurement? A staggering 9 centimeters, barely off by a single centimeter. We were quite amazed how good those early projections were, especially when you think about how crude the models were back then, compared to what is available now. Turnquist revealed. For anyone who questions the role of humans in changing our climate, here is some of the best proof that we have understood for decades what is really happening and that we can make credible projections. But here's the part most people miss, and it's the part that should concern us all. While the overall sea level predictions were impressively accurate, scientists significantly underestimated the contribution of melting ice sheets by more than 2 centimeters, approximately 1 inch. This might not sound like much, but in the world of sea level rise, every millimeter matters. The satellite monitoring revolution began in the early 1990s, when space-based instruments started measuring ocean surface heights with unprecedented precision. These measurements revealed that global sea levels have been rising at an average rate of about 1/8 of an inch per year. More recently, scientists detected something even more alarming. This rate is actually accelerating. In October 2024, NASA researchers made a startling announcement. The rate of sea level rise has doubled during this 30-year monitoring period. This acceleration provided the perfect opportunity for the Tulane team to conduct their comparison with those decades-old predictions. Sönke Dangendorf, co-author and David and Jane Flowery Associate Professor in Tulane's Department of River, Coastal Science and Engineering, emphasizes a critical point that often gets overlooked. Sea level doesn't rise uniformly. It varies widely. Our recent study of this regional variability and the processes behind it relies heavily on data from NASA's satellite missions and NOAA's ocean monitoring programs. This regional variation is where things get really interesting and potentially controversial. While global averages provide important insights, coastal communities need hyperlocal data to make informed decisions. Continuing these efforts is more important than ever and essential for informed decision-making to benefit the people living along the coast, Dangendorf explains, particularly referencing vulnerable regions like South Louisiana. And this is where the story takes a dramatic turn. Back in 1996, scientists knew relatively little about how warming ocean waters could destabilize massive ice sheets from below. Particularly the marine sectors of Antarctica's ice sheet. The Greenland ice sheet has also been losing ice to the ocean faster than anyone predicted 3 decades ago. These past difficulties in predicting ice sheet behavior carry a sobering message for our future. Current climate projections now consider a possibility that would have seemed like science fiction in 1996, the potential for catastrophic ice sheet collapse before the end of this century. While scientists classified this scenario as uncertain and of low likelihood, the consequences would be devastating, particularly for low-lying coastal regions across the United States. Here's what makes this study so compelling and potentially divisive. It simultaneously validates the accuracy of climate science while highlighting how conservative past estimates may have been. The fact that ice sheet melting exceeded predictions by such a significant margin raises uncomfortable questions about whether current projections might also be underestimating future changes. This research arrives at a time when climate science faces unprecedented scrutiny and political polarization. The accuracy of these 30-year-old predictions provides powerful evidence for the reliability of climate modeling. Yet the underestimation of ice sheet contributions suggests that our current situation might be more serious than many realize. So here's the million-dollar question that this study raises. If scientists got the big picture right but underestimated one of the most critical components, what does that mean for the projections we're relying on today? Are we potentially facing a future where sea level rise accelerates even faster than our most recent models predict? The implications extend far beyond academic circles. Coastal communities, urban planners, and policymakers are making decisions today based on current sea level projections. If history teaches us anything from this study, it's that while scientists excel at predicting overall trends, the most dangerous elements, like catastrophic ice sheet collapse, might be the hardest to forecast accurately. What do you think? Does this vindication of 30-year-old climate predictions strengthen your confidence in current climate science? Or does the significant underestimation of ice sheet melting make you more concerned about what we might be missing today? Should we be preparing for scenarios that current models suggest are unlikely but could be catastrophic if they occur? The comment section awaits your perspective on this fascinating intersection of scientific accuracy and potential blind spots.